Okay guys, here is a molecular and empirical formula example. This is the one that was shown on your molecular versus empirical formula summary chart. So I'm just going to go through the steps in case you need it. So here's our question. Let's read it. So a compound is composed of 52.14% carbon, 13.13% hydrogen, and 34.73% oxygen by mass. A. What is the empirical formula? B. What is the molecular formula if the molar mass of the compound is 138.204 grams per mole? Sounds easy. Let's try it. So let's color code this. So we're going to start with A, right? Just going to put the question up here. So A is asking us for the empirical formula. I'm just going to put Emp form. So let's write down what we know. So it says carbon has 52.14%. What else do we know? We know that hydrogen has 13.3. And we know that oxygen has 34.73%. What else do we need to figure out empirical formula? We need the molar mass of each one. So we find molar mass by looking at periodic tables. Carbon is 12 grams per mole. Hydrogen, 1 gram per mole. And oxygen weighs 16 grams per mole. So what are we going to do with these two numbers? So this is saying if we had 100 grams of this compound, then 52.14 grams would be carbon, 13.3 grams would be hydrogen, and 34.73 grams would be oxygen. So in order to find this ratio, we're going to divide this by this, such as we're going to do 52.14 divided by 12 so that we get our mole ratio. We're going to do 13.13 divided by 1, and then 34.73 divided by 16. I can show you in a different video how these units cancel out. So basically, this is grams and grams cancel, which leaves us with a mole ratio, which is what this is. When I pop these in my calculator, I get 4.345. This one is obviously just 13.13, and then this one I get 2.170625. Cool. Now our next step is to make these numbers relative to each other by dividing all of them by the lowest number. So this 2.17 is the lowest number. So we're going to divide each of these by the lowest to give us our final ratio. So I have C, which is going to be 4.345 divided by 2.17, which gives us 2. And I have my H, which is my 13.13 over 2.17, which gives us 5.99, which is basically 6. And then my last one is oxygen, which is 2.17 divided by 2.17, which obviously just gives us 1. And that's our ratio. So our final step is to just write how many of each element we have as a compound. So I'm going to do C2, H6, O. And that's it. Cool, so now that we have the empirical formula, we can find the molecular formula. And the molecular formula is how many of each atom we actually have. So let's put molecular form. Okay, so what do we need for the molecular formula? We need the molecular mass of the entire compound. So that's what we know. We know that the molar mass of the compound is 138.204 grams per mole from the question. Now, what are we going to do with this number? We need something else, right? What else is it that we need? We need the molar mass of this. We need the molar mass of the empirical formula. So let's calculate that. We have C weighs 12 grams per mole. And how many of them do we have? We have 2, which gives us 24 grams per mole. H weighs 1 gram per mole. How many of them do we have? 6, gives us 6 grams per mole. And then oxygen weighs 16 grams per mole. And we have 1 of them. So you have 16 grams. If we add all of these up together, we get 46 grams per mole. Oops, can you guys see? Cool, we have 46 grams per mole. Now, we just need to see how many times this can go into this, right? If this is the empirical formula and this is the mass of the actual compound, we're just going to divide this number by this number, and it's going to tell us what we need to multiply the empirical formula by. So here we go. I'm going to do molar mass of compound divided by the molar mass of empirical formula, which is going to give me 138.204 divided by 46, which gives me 3. Okay, let's push this up. So we have that it is 3. Now I just need to take, what am I going to do with this 3? I'm going to multiply the empirical formula by 3. So I have the empirical formula, which was C2H6O. I'm going to multiply it by 3 from here, which is going to give me C. 3 times 2 is 6. H, 18. O, 3. Cool? So our molecular formula is C6H18O3. And that's it. Cool? Cool.